Hi, this is Dr. Ocular again for Mind's Eye Models. Today we're going to talk about one of the more important topics in organic chemistry, and that is stereoconformers of six-membered rings. These are referred to as chairs and boats in most textbooks. As you can see, here I have a chair position, much like a chaise lounge, with a six-membered ring, 1, 2, 3, 4, 5, 6 carbons, and here's its other conformer where the positions have been reversed. The rings can flip from one to the other by going through the boat conformation, and our model kits do an excellent job of showing this. A six-membered chair that I pre-assembled before we started the video shows the chair conformation quite effectively. You can see that the foot support and the head support for the chair are there. The remaining pins represent the hydrogen atoms that would be attached to those carbons. I can flip from one conformer to the other by going through the boat conformation and then flipping down the other side to get to the chair on the other side. Now, most important in this is that these six-membered rings in molecules are going to assume the conformer that is lowest in energy for them. And the energy related to those rings arises from the interactions of these axial positions that come up in a straight line from the ring, and those that stick out in an equatorial position, sticking out away towards the equator of the ring. In our model kit, you can very easily add hydrogens to these rings to make cyclohexane. And what I'm going to do is just put all of the axial hydrogens on and leave the equatorials alone. So we're going to have 3 axial positions on the top face of the ring and 3 axial positions on the bottom face of the ring, giving us our chair with our 6 axial hydrogens. Now you'll see that when we flip to the other conformer, all of those hydrogens become equatorial. Very easily displayed and easily understood with this kit. Simultaneously, all of the previously equatorial positions have now become axial. So the important thing here is that when you're flipping from one conformer to the other, the axials are converted to equatorials and the equatorials are converted to axials. The molecule will assume the conformer that is the lowest in energy. So, for example, if this ring had a tert-butyl group on it, which is a carbon that has a 4-carbon piece attached to it, like this, and then each of those carbons is going to have 3 hydrogens on it, which I'm not going to put those all on for the sake of saving some time. But you can clearly see that when that tert-butyl group is in the equatorial position, that it's not in much conflict with the axial positions here. But as soon as I go to the other conformer, I now have created some conflict between the carbons and hydrogens on the tert-butyl group and the adjacent 1,3 diaxial hydrogens. Again, very easily shown with this model kit about how these things will sterically interact with each other and create a uncomfortable or higher energy situation for that ring. The ring would much more prefer to have that T-butyl group in the equatorial position, and it is no longer in conflict with those 1,3 diaxials. There are axials here, but you can see that because this is sticking out from the ring at a very shallow angle, that there's very little steric interaction between those compared to the 1,3 diaxials. We hope this clarifies how you do this and put them together. 6-membered rings as well as a tertiary butyl group. And again, it's Mind's Eye Models, and we hope to hear from you. Thank you.